Hi everyone, how are you? Welcome to the class MATE3018. My name is Lin Shan and my email address is lin.shan@upr.edu. This class is a summer course. It is a very dense, but it still contains 75 hours lectures. So every day we will have 2.5 hours. So we will have 6 weeks. In these 6 weeks, we will have 3 partial exams. And 1 final exam. Okay, so you will have 4 exams and you have 4 points. For example, you have the points of partial exam 1, the points partial exam 2, points partial exam 3, and final. Final, we will double your final. There's only 1 final exam, we will double your points. And then you see here, you will have 5 points. From those 5 points, we will remove the worst points from those 5 numbers. So you have 4 numbers. You add all those good 4 numbers and divide it by 4. This is your final points. It's a final points. Based on your final points, we will have A. A is 85 above, including 85. B, 75, 84. C, 65, 65 to 74. And D is 60 to 64. Of course, you know what F is. Below 60 is F. Lower than 60 is F. Okay, so that's the final grade. In your notes, possibly you will only see A, B, C, D, but I will send you your original points after every exam, so you know your original points and you can also compute your A, B, C, D in case I make some stupid mistake. Okay, and I believe all of you already received the Bosquejo file. In that file, we will follow the orders. We will start the section one by one, and there are recommended exercise for each section. I hope you do all the odd problems of those exercises. If you have time, of course, you can do all of them. But if you feel you don't have enough time, you need to do at least odd numbers of the exercises. But we cannot collect your exercises. So if you have questions about exercises, you can send me email. If I will either answer your question by email, or I will answer your questions in the next videos. So I will definitely answer your questions. You don't have to worry about that. And what else? Yeah. Except that anytime you have doubts about lectures, or you have some other exercises outside of the recommended exercise, if you have questions, you can ask me. For the 3 partial exams, we will have practice exam. The partial exam will be similar to the practice exam, but I cannot guarantee that it's just restricted to the practice exam. Practice exam will possibly cover at least 90% of the partial exams. Maybe the partial exams come from your recommended exercise, okay? But there are no practice exam for the final. No practice exam for final exam. So you can use all the practice exams plus the partial exams to practice and to prepare for the final exams. Okay, so that's the practice. And what else? Yes. So all the exams contain 100 points. All exams are 100 points, but I will give you 10 bonus point. So from on each page, on the exam page, you will see 110 points. But bonus is a bonus. So if you get 110, we will count it as 110 in this computation. Okay, we will not compute the percentage. It's just 110 in the row computation, and that's just the bonus. Okay, so that's the bonus part. Exam exercise. No, I do not collect exercise. And the textbook, yes, the textbook is Algebra Trigonometry, the 9th edition by Michael Sullivan. You can find that in the Bosquejo file. And this textbook, you can find it online. You just Google the book name with Michael Sullivan. You can definitely find the PDF file. You don't have to buy it. Yeah, it's too expensive. You don't have to buy it. And what else? Okay, textbook. Let me write it. Textbook. Algebra and trigonometry. Trigonometry. The 9th edition by Michael Sullivan. Okay, by Michael Sullivan. Yes. For the exams, I will try my best to make exam in Spanish. In case I really have problem to express myself clear in Spanish, I will write it in English. But when you answer the exams, you can answer in Spanish, but write it clear. I can read Spanish. I may not understand when you talk to me, but I can read Spanish. Okay, so you can. Answer exams in Spanish. Okay. Anything else? In the Bosquejo file, I already selected the partial exam test date. So for the partial exam, we will take the partial exam. Partial exam. Will be held from 4 p.m. to 6 p.m. 4 p.m. to 6 p.m. Okay, so you will have that assigned date already in the Bosquejo file. And for the final exam, we need to determine it later. Final exam is to be determined later. Okay, the final exam is to be determined later. We will see what is the proper date and what is the required date from the department. But partial exam, we already selected the date. Okay, so that's possibly the important information for the course. Anyway, if you have any questions, just send me email. I will answer it as soon as possible. Okay, so that's the information of the classes. Okay, very good. Let's start our class. Let me find my Bosquejo file here. Okay, so now we will start from the review section 1. This is the first class, the first page. Okay, so my book. Let me find it. Okay, so the chapter R, review chapter. The review chapter, the first chapter. R.1, the first section, it's about real numbers. Real numbers. Okay, so this section, technically we just try to collect all the words we frequently use and just refresh your memory what those words mean. Sorry. So first, a set. We always talk about a set. Set is a well-defined collection. Set is a collection of distinct objects. Distinct objects. So first, it's a collection. It's a well-defined. Well-defined means you will know if an object is in the set or not in the set. It's not a blur. And distinct means in a set, any two elements, any two objects are different. Okay? Well-defined means you will definitely see if an object is in or out of the set. Distinct means no two objects are the same. And if a set contains no objects, no object, then it is called the empty set or the null set. You can use either name. And it is denoted by the symbol a 0 with a segment. So this symbol means it's an empty set. It does not contain any object. Okay, so for example, set. We want to describe a set. We can use a big parenthesis, like for example, put 0, 1, 2, 3, 4, 5. So this is a set, and it's clear, and no two objects are the same. They're all different from each other. And so that's you just define the set D like this. Then that's it. That's an example. And all the objects in the set is also called an element. It's just name. Different people use different name, and after long history, we use all of them. But sometimes the names mean the same thing. Okay. If you can list all possible elements, you will do this. And sometimes, if you cannot list all the possible elements, because you may have a lot of elements, then you can say this. So here, first we have a set. That D is a set, and then we put X, and we draw this small segment, vertical segment, and we say X is an odd integer. So we will say that D is the set of X. D is a set of X such that X is an odd integer. Odd integer, 1, 3, 5. If you allow negative, here we allow negative, then we will have -1, -3, -3, -5. And you have infinitely many odd integers. So in this place, we cannot list all of them. Okay? When we cannot list all of them, but they have some property, we can write this way. D is a set of all X such that X satisfy certain conditions. Okay? And when you have not just one set, you may have some relations among sets. For example, A is 1, 2, 3, for example, and B is 0, 1, 2, 3. Then we see that all the elements of A are the elements of B. If this happens, if all elements of A are also elements of B, we say that A is a subset of B. A is a subset of B. Okay, and if all elements of A are elements of B, also we can say belong to B, and all elements of B belong to A. This set is a subset of this one, and this set is a subset of this one. Then we say A equals B. We say A equals B, and write A equal B, just like A equal B. Okay, so that's a subset. Here, yeah, sorry, I forgot to write. Subset means we write this way. A is a subset of B, or we can also say A is contained in B. A is contained in B. Let me write A is contained in B. This piece should go here. Okay, a subset. Okay. Now we are talking about more than one set. So if we have two sets, let A, B be two sets. The intersection of A and B, intersection we denote it A intersection B. What is intersection? Intersection is a set consisting of elements that belong to A or both A and B. Belong to both A and B. So that's a intersection with this notation. And then the union of A and B denoted A cap B. Cup, A cup B. This is cap, this is cup. I say this is a cap. This is a cup. Wow. Okay, so this union of A and B is the set consisting of elements that belong to either A or B or both. It doesn't matter. If one case happens, that's correct. Okay, so here we have union. This one. Okay, now let's see the example. We will always understand the concepts by examples, by examining the examples. The example is the following. For example, we have A is 1, 3, 5, 8, and B is 3, 5, 7, and then we have the third one. C is 2, 4, 6, 8. Okay, so we have three sets, as many as you want, or as many as you like. So first, let's try to find the intersection A and B. The intersection of A and B. When you try to find the intersection of A and B, you just see which elements are repeated. So here you see 1. 1 only appears in A but not in B, so it's not repeated. Here you have 3, 5. Those two numbers are repeated or appears in both sets, so the intersection will be 3, 5. This is common. It's not a point. It's a common. Okay, so that's the intersection. And union. What is a union? Union means whenever you see it, you will collect it. All means you will get whatever you see. So from A, you see 1, 3, 5, 8. Then from B, 3 and 5, they are repeated. Remember that in a set, you don't repeat numbers. So 3, 5, they already appears here, so you don't copy. But 7 does not appear in A, so you put 7 here. So this is the union of A and B. You must collect all the different objects from A and B. C, we are trying to find the intersection of B with the union of A and C. So the set operation is very similar to the numbers operation. You must follow the order. When you have the parenthesis or brace, you need to compute what inside first. So in order to compute this intersection, you have to find the A union C. The union of A and C, let's check the union. Union means you collect whatever you see. So you have 1, 3, 5, 8. 1, 3, 5, 8. And then you check C. C is a 2, 4, 6, 8. 8 is already here. So you only collect 2, 4, 6. So this is the union of A and C. Okay, that's important. You have to compute the inside first. Once you get the union of A and C, then B intersect A union C means you compare B with A union C. You see what odd elements are repeated. You check also only 3 and 5 are repeated. So this is a 3 and 5. Okay, so that's the intersection composed with a union. Okay, so composed with a union. That's a union and the intersection. Okay, so next we want to talk about so-called the complement. What is a complement? Normally, when we talk about numbers, we always restrict ourselves to a certain range. For example, we always say, let's talk about integers. Okay, so that is our universe. We don't think about rational numbers at all, only integer. And then among integers, we can talk about, okay, now we talk about odd integers, and we talk about even integers. Okay, so everything are restricted to the integer set. So the integer set is our universe, so we usually designate a universal set. The universal set. Universal set is the set consisting of all the elements that we wish to consider. Of course, for different problems, this universal set may be different. Okay, so possibly for the first grade in the elementary school, the universal set will be always integers or even positive integers, 1, 2, 3, 4, 5. When they grow, they will study the rational number. Then, in their mind, the universal set will be the rational numbers, 1/2, 2/3, stuffs like that. And later they will say, okay, we learned the negative number, then our universal set is positive numbers, negative, rational, positive, rational. And after they learn the disks, when they learn the area of the disks, circumference of the disks, they will learn the pi. At that moment, they first notice there are not just the rational number, they have so-called irrational numbers, then that is the real numbers. So for different time, you will have different universal set. Even when they go to the high school, they possibly will, for the different problem, they will say, okay, let's just think about integers. So the universal set is selected for the specific problem or for the common sense. For our common sense, we only use this, or we only wish to consider this big class of set. So universal sets are designed for different problems. So whenever you want to use universal set, you have to clearly describe what universal set is. Okay? Okay. Assume we already have a universal set. Oh, sorry, this is a 3. Assume we already have a universal set. For example, integer set, all the integer numbers. Okay, if A is a set and the complement of A denoted A bar is a set consisting of all the elements in the universal set that are not in A. Okay, so complement means it has to be in the universal set, but it has to be not in A, outside. That's a complement. Okay, for example, in order to make all the problems very simple, we choose a simple universal set and simple set. Okay, so the universal set U, we define it to be 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, and a set A is 1, 3, 5, 7, 9. Okay. Then let's see. 1 is inside the universal set, but 1 is also inside A, so 1 is not in the complement. So we're trying to determine the complement of the set A. So you just see which element appears in U but not appear in A. You will see here A contains all the odd numbers, so we will just select all the even numbers. Okay, so that's the complement of A, the complement of A. And of course, if we change this universal set, the complement also changes. The complement depends on the universal set, the selection of universal set. Okay. So another example, let's say the universal set is x. X is an integer, for example. And A, x is an odd integer. Then what is the complement of A? The complement of A, integer, either even or odd. Here, A is an odd integer, collection of all odd integer. Then the complement of A is x is an even integer. So you see, the complement of A is a set of all x such that x is an even integer. Okay? That's another example. Okay. In the study or in the description of the set word, there is a very useful technique. It's called the Venn diagram. So what is a Venn diagram? Venn diagram is the following. First, we prefer to draw a rectangle slightly large. We prefer to draw a rectangle, and then we consider the region enclosed by the rectangle is a universal set. So this inside is a universal set. Then we draw a circle. We have A. We have A. So this is a set inside universal set. When you have A, you have universal set. Where is A bar? A bar is outside. Inside is A, outside is A bar. So this is A and A bar. A and A bar, they do not belong to each other at all. So, but A and A bar, you see that if you include inside, include outside, the union will be the universal set. And A and A bar does not share any same elements. So the intersection is empty. The intersection is always empty. Okay? And another Venn diagram, let's try to draw this. So again, this rectangle is a universal set. And we have A and we have B circles. Then from here, because those two circles do not overlap, this Venn diagram represents the intersection of A and B is empty. Okay, another one. Then for the Venn diagram, what is a subset? We have a small circle, we have a large circle surrounding it. This is B, this is A. Then this represents A is a subset of B. A is a subset of B. The rectangle is always the universal set. And the intersection is like this. We have a circle A, we have circle B. This time they overlap. Then this overlapped shadowed region is A intersect B. The overlapped shadowed region is A intersect B. And union A and B, possibly in overlap, possibly not overlap, whatever. Then you just get all the regions covered by the A and B. This is A union B. A union B. Okay? So that's a Venn diagram. It's an important diagram. It will show the property very clear. Okay. Okay, so after we determine or fix the set language, now let's just collect whatever number we have. We know that we have natural numbers. So natural number. Natural numbers is like 1, 2, 3, 4. Natural number is 1, 2, 3, 4. And be careful, 0 is not natural number. 0 is not a natural number. And if you include 0, 0 is a so imaginary, so it's not a natural. Then we call the whole numbers. The whole numbers starts from 1, 2, 3, 4, 5, and so on. So the whole numbers, the whole numbers are the natural number with a 0. So you include 0, it's called a whole number. Whatever, it's just a name. This name is widely used. A natural number, this name is widely used. You will see this in a different textbook. It's a commonly used name. The whole numbers, it's used in this textbook. You just remember, whole number means a natural number including 0. Okay? That's not a widely accepted name. It's just a name in this textbook. And then all those numbers are positive. 0 is not positive. 1, 2, 3, 4 are positive. 0 is not positive, not negative. Then the integers. Integers contains whole numbers and their negative counterpart. Because there are infinitely many integers, so we usually we write this way. We write it symmetrically. We start from 1, we get a negative, we start from 0, we get -1, +1, -2, +2, -3, +3, and draw the dots. So this is the integers. Integers have positive, 0, and -3 parts. Integers has positive, 0, -3 parts. So 0 is not positive, not negative. Okay? Except integers, we have the rational numbers. Rational numbers are just the set of all x such that x is p over q. pq are integers. Q is not equal to 0. Okay, so no matter what mathematics you study, the denominator is never 0. The denominator can never be 0. And the rational numbers means that you have the ratio of 2 integers. Okay? All the rational numbers, if you do the division, they are either a finite decimals or it is a repeated decimals. Okay? So all the rational numbers will be finite decimal numbers, or the decimal numbers with repeated parts. So for example, if you have 1 over 3, it will be 0.3, because 3 will be repeat, 0.3333, infinitely many. So you draw the bar here. You just draw the bar of a repeated part. For example, if you have a 7 over 66, by your calculator, you will see that it's a 0.1060606 all the time. You have to draw the dots in order to describe this does not stop. And it is denoted by 0.106. Be careful about your writing. This bar is over 0.6. It means 0.6. These 2 digits repeat. You cannot cover 1. Very important. Okay? And PQ, of course, they are called the numerator and the denominator. Okay? So for all the numbers, except rational numbers, we have pi. We call pi irrational numbers. Pi irrational numbers means it's an infinite decimal numbers, but there's no repeated parts. Okay? Infinite decimal numbers, but no repeated parts. So they're irrational. Infinite decimals without repeated parts. So like pi, we all know that pi has no pattern. You have to, if you like or prefer, you have to memorize in a weird way, 3.1 form, stuff like that. No pattern at all. Okay? And of course, irrational numbers cannot be written as a ratio of two integers. All irrational numbers cannot be written as a over b or p over q. If you can write a number as a ratio of p and q, p, q are integers, then it is irrational. Okay? And you put rational, irrational together, you get real numbers. Real numbers is a set or is a union of the set of rational numbers and this with the set of irrational numbers. Okay? Rational, irrational. Okay, so now let's see. For example, natural numbers are integers, whole numbers are integers. So natural number, whole number. This is like expansion. Cover irrational. This is like expansion. Natural numbers are all natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. This is like expansion one by one. But rational numbers, irrational numbers, they do not overlap. Their intersection is empty. So this is like the complement of rational numbers in the universal set real numbers. Okay? Yeah. So yeah, let's say this. This is it's rational. And here outside is irrational. And inside you have integers. And inside you have natural numbers or whole numbers. Okay, so it's like this. Let's see the example. The example is about the classification of integers, the numbers. Let me put it here for a second. Okay. So the example. Assume we have this set, -3, 4/3, 0.12, square root of 2, pi, 10, 2.15 repeated. Okay, so there's 1, 2, 3, 4, 5, 6, 7 numbers. Okay, then in these 7 numbers, natural number, only 10. 10 is a natural number. -3 is not natural, it's negative. And then whole number, there's no zero, so natural number are the whole number. There's no additional one. Then integers. Integers, now we can include -3. -3, 10, they are integers. And next, rational numbers. Rational number, -3 is rational. 4/3, of course, by the definition is rational. 0.12, check here, 0.12, it's a finite integer, decimal. Finite decimal, 0.12 is a 12/100. 12%, right? 12/100. 12/100, of course, it's a ratio of two integers, so it's a rational. Square root of 2, I don't know if you learned it or not. Square root of 2 is irrational. Square root of 2 is irrational. It cannot be written as a ratio of two integers. And pi is, of course, is a famous irrational number. 10 is an integer. Integer is rational. 2.15 repeated. This is a rational number. So that's all rational numbers. And irrational numbers. Irrational numbers, just square root of 2 and pi. Okay, that's irrational numbers. A real number, all the numbers are real numbers. All these numbers are real numbers. All these numbers. Okay. Let me see. The other one, we have the approximation. We will finish this, and the video will stop, and we'll get another file. Okay, approximation. Approximation, for example, square root of let's just use a pi. Pi is approximate is approximately 3.1416. And there are two ways to approximate a number if it's not finite, or if it contains too many terms. So for example, there are two methods. One is called the truncation. Truncation means you just drop all the digits that does not required. So drop all the digits that follow the specified final digits. Final digits in the decimal. Okay, for example, if we only keep two digits after dots, like for example, if we keep 3 digits after dots, it will be pi the approximately 3.141. If we only keep 3 digits after the dots, I don't care what's next digits, we just cut it. And second is called the rounding. Rounding means you will also check the next the next digits. If the digit is greater than 5, you add a 1. Greater than 5. If it's less than 5, you just cut it. Okay, so if you have a rounding pi, if you keep 3 digits, it's approximately 3.142, because 6 is greater than 5. If it's greater than 5, you will add 1 you get 2. Okay, so this is a rounding. So we always have two methods to approximate some long decimal numbers or complex decimal numbers. Okay, so my cell phone can only make a video for like 55 minutes. I will stop this video and start another one.